Hello! Hi everyone!
Hello.
You turn down the music. Possibly. Oh, let me turn it back up and then turn it down over here.
It's just our heads.
That's right. People always complain about how I make the PNGs too big, so this time I didn't.
Okay.
How are you guys, Dawn and Fiyera?
Good.
Tired.
Yeah, me too. We're doing it anyway. How do you think I watched your debut, Dawn? It was great.
Thank you.
Very excited to have you all debuted. Fun.
Yum. Yum.
Yum.
Yum.
I loved it. It was so cute. It makes me want to do a little PowerPoint.
It was very fun to put together.
Okay.
Yeah, Mickey asked for feet pics and cup size.
Yeah, Mickey, what's your deal? What's your problem? Why are you being a freak?
I was just being silly.
Oh, you silly guy.
Oh, you silly guy.
Benny in the chat, how are the levels?
Happy holidays.
What? Happy holidays?
I said stop yawning.
Oh, stop yawning.
Sorry, me yawn.
Happy holidays. Benny.
Benny in the chat.
Benny in the chat. Music could be down a bit.
Be down
Okay,
a bit.
wonderful.
Music could be down a bit.
Get down with it.
How's that?
Maybe it's just my brain not working. Sometimes that happens.
Yeah.
Sometimes that happens, yeah. I don't know if that did anything at all.
So
Dope. Are you saying dope, or did you misspell nope?
Or you're a dope.
Or I'm a dope?
oh, I assumed it was good dope.
Okay.
Like
Alright.
Lady
I'm not
Gaga
Benny.
song.
It's like the Lady Gaga song.
Okay, so today we're gonna be talking about the number 9. The
Number 9?
Number 9? Number
Um,
9?
Something
Nine.
about this topic gives me a little deja vu.
I can't imagine why.
No reason, I'm sure.
So what do we know about the number 9?
It's between 8 and 10.
True.
That's so true.
Mhm.
Wait,
It's-
is the joke I told you relevant?
What relevant? What joke?
The 7, 8, 9 joke?
Sure, yeah. Why not?
why is 6 afraid of 7? Because 7, 8, 9, that one?
Okay,
No.
here's the joke.
We all know that 7, 8, 9.
Yeah.
But did you know it's because 7
Yeah?
7
So why, Don, why did 7 eat 9?
because 7 should have 3 square meals a day.
Oh, right, yes, I've heard that one. I wonder who I've heard it from.
What?
So that is good, because one of our facts about 9 is that it is the first perfect square. The first odd perfect square.
Huh?
Yeah,
How can you
besides
be odd
4.
and perfect?
How can you be odd and perfect?
And perfect. It's called me. Thank you very much.
Or is it the first perfect square? I don't know. Do we count 1 square? I'm not sure. But 3
It's
squared.
kind of like cheating.
It's not the perfect square. That's not true, because we have all of these.
You
Yeah.
freaking lied to
We
us.
have all of these, but it is the first odd perfect square. So we have, well, 1 square doesn't count, but 2 squared, 3 squared, that's 9. That's odd. First one. Anyway. I'm losing myself already here.
It's all
It's
good.
okay.
I'm sorry for confusing you.
Yeah, lose yourself in the moment.
Music.
Lose yourself in the music, the
I'm
moment.
spaghetti.
the-
And then never. They used to play that
You
song
got it.
on the Universal Studios tram tour.
Interesting. During which part?
Alright. I always associate the part where you go down the hill and they tell you about Ronald Reagan.
Oh, of course. I mean, it was his song, so.
I'm drinking water.
Mickey's stunned. Oh. Oh, I was thinking that I should get a streaming water bottle so that I can drink water without a sound.
Sure. I highly recommend my water bottle. It's called Summit from simplemodern.com.
It's
So,
a little too big for me.
Are
I
you
got it at
are you
Target.
assuming that your throat and your mouth aren't gonna make sounds?
Well, it's mostly the slurp sound.
Okay.
Someone's making toast, I think.
It's not me.
I want toast.
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 Good bit, everyone. Toast.
Toast.
Oh, people come here for the jokes.
The toast jokes, of course.
Okay. So 9. First, so we're gonna start out with a little magic trick.
Oh,
So
okay.
what I want each of you guys to do. Do you guys have like pen and paper handy or something?
1 second.
Give me 1 second.
Okay.
I almost grabbed my passport and I was like, I can write in this.
Yeah, probably not the best idea. Okay, I have
Hold on.
a card. You guys need to, because your guests, I don't need to do S word. I'm a fan. That's true.
S word. When I was
Shiitake
rewatching my stream, I noticed that I say freaking a lot.
Do you? I didn't notice that. You need passport to get to Earth. Yeah.
Yeah.
It's not like the Dominican Republic where you can just travel there from
It's
the
not like
US.
Dominican Republic, okay?
That's only a part of it. Okay,
You really
I have
don't
my
need a
pen and
passport
paper.
to go to the Dominican Republic?
You don't need a password to go anywhere except for the internet.
I said passport.
And maybe a
I
speakeasy.
said passport.
I
Chat
thought.
way in.
Am I thinking? I guess I thought so. I thought it was like Puerto Rico, Dominican Republic, and something else. You don't need a passport.
Well, definitely Puerto Rico because it's an American territory.
Right.
I know that you didn't used
might
to
just
need a
be
passport
wrong.
to go to Mexico or Canada, but now you do.
Correct.
In Guam,
And shit.
colonization. When are you gonna teach a class on that?
On colonization?
Yeah.
I'd be happy to. I have taught classes on that.
It is a hot take. No one else has said that. Colonization sucks. Alright, not to. Yeah, we should change subjects. Back to. I want to see your magic trick.
Yeah.
Me
okay.
too.
You
I'm
guys
ready. I have my paper. Yes,
Yeah.
yes.
Okay.
Do I need a calculator as well, Sire?
Yeah, it would probably help.
Okay, hold
Okay,
on.
let me open my
Hold up.
phone application.
When I opened the calculator, it had 60,000 written into it. What do you think
Ooh.
that means?
Dollars?
Oh, that's how much I'll get from streaming this month?
Yeah.
Yeah. Okay, I'm ready.
Okay.
Me too.
So let's write down any number at all, but let's make it kind of a long number. That's the best way to do this trick. You don't have to, but let's make it kind of a long number. It's like 4, 5, 6 digits, something like that. So for my number, I'm gonna write down 8675309.
You're not writing anything.
Yes, I am.
Oh, there it is.
It's delay.
Sorry. I have idiot disease.
That's not 4 to 5 digits.
I did 7.
7. You said 4 to 6.
Okay, well, you can do however many you want.
Okay.
It just is cooler if you make it a longer number. That's all.
Okay, I'll add numbers onto it.
Should it be a lot of different digits?
Doesn't really matter though. You could do 5555555. This trick would still work.
Would it?
Okay, I have mine.
Okay?
Mhm.
Everybody has their number?
Yes.
Okay. Now, what we want to do is we want to rearrange the digits in this first number
Why?
to make a new number.
Huh?
So
What do you mean?
So for me, I could say, and it's easiest if you make it a number that's smaller than this one. So you
What?
could say, okay, my rearranged digits are 6, 5, 6, 5, 3, 0, 9, 7, 8.
What's the point of this?
Well,
This isn't a math trick. This is just rearranging numbers.
it's not over yet.
I don't think the
I
trick
assure
isn't
you.
done yet.
I assure you that the trick is not over yet. The trick was not just write a number and then write this rearranged number.
Wow, that's amazing. It became a completely different number. Okay, I did it.
I did it.
So, like I said, it's easiest if you make the second number smaller than the first number.
I did.
But
I
if you
did.
didn't, that's fine as well.
I did.
You just want to put the biggest absolute value on top. Okay, so now what we're going to do is we're going to subtract those two numbers.
What the hell?
Okay.
Okay.
Definitely gonna use my calculator.
Yeah, when it's a big number like that, it's probably easier to do.
Okay.
Hold on.
This isn't supposed to be 9, right?
No. Why, did you get 9?
No.
Okay.
That would be funny, though.
Okay.
I'm doing mine now. 3, 0, 9, 7, 8.
2, 8, 2, 7, 6, 5, 2, 8. I'm trying to mess you up.
I already did it, so nice try. Okay, so what I got was 1, 3,
2, 5,
4.
8, 9.
Okay.
A, B.
Now, I can promise you that this number and the difference that you guys both got, Dawn's difference and Fiyera's difference, are multiples of 9.
I don't know about that.
I can't.
And here's how you can check. You still have that number on your calculator? Divide it by 9. Do you get a whole number or no?
I did!
I did too.
Wow.
Wait, I want to be contrarian. No, I did not.
You didn't get a whole number?
Yes. I'm not lying.
Okay, so that's not possible, and I'll tell you why at the end of this session.
Okay.
So, guys, hold on to your numbers, and then we'll redo them together at the end, and I'll show you why this works.
My kitty is here.
Hi, kitty.
A kitty. Meow.
He smells bad.
Okay.
So you can do that with any number and then rearrange, and then it's 9.
Yep.
That's crazy.
I'll tell you why at the very end.
David Blaine has nothing on you.
Yeah, literally.
So let's see. Other facts about 9. We talked about how it's a perfect square. We talked about how. Oh no, we didn't talk about this. It is the only single-digit composite number that is odd. So we have all the single-digit numbers.
Composite. What does that mean?
Composite means not prime. So it's gonna have more factors than just 1 in itself. So 1 is not prime.
Okay, I see.
2, not prime or composite. 2 is prime. 3 is prime. 4 is composite, but it is even. 5 is prime. 6 is composite, but it is even. Same thing here. Composite and odd. Wow! So that's the first odd composite number. The only single-digit composite number that is odd.
Did you explain what a composite number is?
Yes. So a composite number is a number that's not prime. So do you know what a prime number is?
Yes.
What do you think a prime number is?
Multiplies to be it.
Multiply
me.
to be it?
I'm mapping, but I'm in the same boat where it's like I know what it is, but do I?
Okay, so you're on the right track. So
You can multiply two number of same number be to it.
no, that
What?
so you're thinking of a perfect square. So 3
Oh,
times
okay.
3, that would be 9. That's a perfect
Yeah.
square. Okay.
Yeah.
But it does have to do with multiplication. So let's take the number 5. If we were going to split up the number 5 using multiplication, what could we do? What two numbers will we get to multiply to 5?
2.5 and 2.
Whole numbers.
Oh,
Whole
nothing.
We're
numbers.
talking about factors.
Oh,
we were
5
just
and 1.
talking
1
about
and
One.
5.
whole
What do you mean
numbers.
Oh my
nothing?
That's right, 1 and 5. So obviously we know all numbers have this property where if you split it up into 1 in itself, it multiplies to what it is, right?
So true.
But what's special about prime numbers is that you can't split it up into any other multiplication problems. If you try and think about it, you can't get 5 from any other multiplication problem with whole numbers, right? You can't be like, oh, 3 and 4. No, that's not 5, that's 12, right? It's only 1 and 5. So that's a prime number. It's the number that its factors are only 1 and itself. This is the same thing with 7. You know, it's only 7 and 1. This is the same thing as, I don't know. Come up with another one of those prime numbers. I don't know. 13. Right? It's just 13 and 1. So a
Whoa.
composite number is the opposite of a prime number.
I see. Okay. That
Yeah.
makes sense.
So a composite number will be something like 25, where we can do 25 and 1. That's true. But we can also do 5 and 5. So it has factors other than itself and 1.
Right.
Does that make sense?
Yeah.
Yeah.
Okay. So 9 is the only single digit number that fulfills the two requirements, that it's composite and it's odd. Let's see. What else? Okay, so this is less a fact about 9 and more a fact about pi. But
Cherry.
Yum.
no, circle type.
They're all circle type usually.
You're right.
Except maybe a hand pie.
Like those McDonald's ones.
Those are not real
Those
food.
are good as hell. I love apple pies at McDonald's.
So good as hell.
I love apple pies from McDonald's.
I do.
Love. Go on, Mickey.
So there's a part in pi that goes like this: 1, 1, 3, 4, 9, 9, 9, 9, 9, 9.
Wait, 9.
Exactly, like Herman Cain.
Did you know that the number 9 is also one of the more edible numbers?
Why is that?
Explain.
Because it's kind of like 9.
Oh, okay, like none. Yeah.
People in the South use it because they go, I love the number 9.
Non.
9.
So anyway, that's kind of
Nope.
weird. There's just like 6 nines in pi for some reason.
Well, pi is infinite.
It
Isn't
is. It is. It is.
So
infinite.
doesn't that mean that technically there's 6 ones at one point and then 6 3s at one point and 6 5s at one point?
Not necessarily. That could be true, and actually it probably is true, but I don't know that it definitively is true.
Oh, it's
Indefinitely.
Yes. I mean, there are like websites that like have generated pi up until like a bazillion gazillion digits, so you can like look through that if you want to.
Can I ask a really stupid question?
Yeah, go for it.
It doesn't end, right?
It does not end.
It's infinite.
If
I
you-
just said that.
If you'll remember from our stream on on rational and irrational numbers,
Yeah.
so pi is an irrational number, which means that it goes on forever. It's a decimal that goes on forever, but it does not ever repeat.
Oh, yeah.
So it doesn't end. Yep.
That's crazy.
yeah.
Actually, that freaks me out.
Oh,
Okay,
I'm sorry.
moving on. That's okay.
I probably will do a math chat on circles, so we'll be talking about pi some more. Not necessarily the infinite nature of pi, but we will be talking about pi. Okay, so now I'm gonna give you some division problems that you guys are gonna type on your calculator. Ready?
What the hell? We got homework?
Okay, 1 second. Let me open back up my calculator.
I scared my kitty.
Nice going. Weirdo.
You ready?
Yes.
Okay.
Yeah.
Here's the first one. 1 divided by 9.
0.11.
0.1 repeating, right? 0.111111, right? That's what you get?
I have a question.
Yes.
Yes.
So when decimals like that are repeating, are they also infinite?
Decimals what?
When they're repeating like
Uh-huh.
that, like 1/3, are they also infinite?
It depends. Some decimals can repeat and terminate, meaning they end at a certain point. Some decimals can repeat and they are non-terminating, which means they can go on forever.
Okay.
So it really depends.
What are you doing?
We're actually going to talk about 1/3 in a second here.
That's crazy. What does that have to do with 9?
You'll see. There's something very special about the way we convert repeating decimals to fractions that have a lot to do with 9. So, what don't you like? Benny says, yeah, I don't like it. I'm watching a stream. What does that mean? What don't you like?
Yeah, I don't like it. Yeah, I don't like it was in reference to the infinity of pi.
Oh, got it. Okay. Let's try another one. Let's try 2 divided by 9.
Two divided by 9.
Loving this ragtime.
Google just let me know that Saturday Night Live is on tonight. Thank you, Google.
Wait, on Saturday night?
Yeah. Okay, it's 0.2 repeating.
Oh, I didn't do it. Hold on.
I did it.
What
I'm
is it?
checking your
0.2
work.
repeating? Okay.
It's 0.2222222.
That's right. So it's 2 and it goes on forever. All right. So knowing
You
this,
give it a hat.
knowing
Infinity
this,
hat.
what do we think 3 divided by 9 is?
0.3 repeating.
0.3 repeating.
I
What
did
about-
it. It is.
What? You
I
did it
did
and it is?
And it is.
Okay,
I
good.
did it and it is.
What about 4 divided by 9?
This is freaky. 0.444444.
Uh-huh. What about 5
Yeah.
divided by 9? Just keep going for a little bit.
Ugh. 5. Wait, what? Is this right?
What is it?
0.555555556?
No, that
Oh,
is
that's
not
because
right.
it round.
Yeah,
It probably
I think
rounded.
your calculator is probably rounding it.
Oh, okay.
But
Whew,
it's 5.55555 repeating. Or
I
0.5
freaked.
repeating. What about 6 divided by 9?
0.6 repeating.
0.6 repeating. What about 7 divided by 9?
7.
0.7 repeating.
Yeah, what about 8 divided by 9?
0.8
8.8
repeating.
repeating.
And what about 9 divided by 9?
1.
1, you can't
Can't
trick
trick
me.
me.
It's 1.
You tried to trick me. I am all
can't.
for it.
Yes, Veronica, we know about rounding. Yes, we're talking about bossy numbers here. Yeah, you guys couldn't be fooled. 9 divided by 9 is 1. But, to be fair, that's pretty close to 0.9 repeating. So, what we've just shown is related to the way that 9 relates to repeating decimals in general. Okay, so let's have a scenario here. So imagine we did 3 divided by 9, and we said to ourselves, okay, well that's 0.3 repeating, so that's 0.3 with a bunch of 3s, and we, they go on forever. Right?
Yeah.
Okay, so let's see. So what can we do here? Well, we can multiply this number by 10, which moves our decimal point right like that, kind of. So now it's 3.3333 repeating. And let's see, I don't know, what can we do now? Well, we can subtract the original number from this number. Stick with me here. I know that this is kind of arbitrary so far.
I'm here.
I'm here.
Okay, so we subtract, and what do we get? 3., well, this 330, 330, 330, 330, 303. Okay, we get 3.
Yes.
Interesting. Okay, so if we have our original decimal, we subtract that decimal from the new decimal times 10, we get 3. So we can rewrite this like this. So 10 times our original fraction, let's call it f. This guy is f. 10 times
F.
our original fraction minus this, our original fraction, is 3. Okay, so if we were to write this using algebra, we could do it like this. 10f minus f equals 3. But now we can simplify this side, can't we? So what's 10f minus f?
10.
9F.
9f.
Oh.
What did you say?
Nothing.
No, I want to know.
No.
She said 10, which I understand, but it's 9f. Do you understand why it's 9f?
Yes.
Yeah, okay.
I'm sorry, don't mean to be making fun of you.
Well, how do we solve for f here?
For the viewers at home, I'm not playing it up. I have like a learning disability.
You're doing good.
Okay.
Divide by 9.
Yep, divide by 9.
Wait, and then you go back to the thingy.
That's right. 3 over 9. So what we've done just now is all is completely legal. We've shown how, just like you said, 3 divided by 9, which is what we end up with, is what we started with, right? So we know now, we've proven that 0.3333 repeating is the same as 3/9, which is the same as what fraction?
3 over 9.
3 over 9, yeah. Can we reduce it?
0. What?
1/3.
1/3.
Oh, fuck.
Yeah, because we divide top and bottom by 3. 3
Yeah,
divided
yeah,
by 3 is
yeah.
1. 9 divided by 3 is 3. So, Fiyera,
It's
there you
behind your
go.
big fat head.
Oh, it's behind my head. Oh no. There it is, 1/3. See it?
Yeah.
So we did that. So that's something interesting because we see that our repeating decimal is going to turn into a fraction over 9. Okay. Now, that's when we just have one digit repeating. We have this 3 and it's been repeating over and over and over again, right? Let's do one where it's 3 digits repeating. How about that?
Oh my
Okay.
god.
Let's see how that relates to 9. So we have
Okay.
0.123, 123, 123, like a waltz. Repeating. And let's see. So there are 3 digits. Now, when we only had 1 digit repeating, we multiplied the number by 10. So what would we multiply this number by?
What?
So when we had 1
100.
digit repeating, 100? Okay, so
1,000.
close. So I see what you're
1,000.
saying. 100 does have 3 digits in it, but what we want is the zeros. We want 3 zeros. See, we only have 1 0 here.
1,000.
1,000.
So 1,000. So we'll multiply this guy by 1,000. Okay. So that kind of looks like this. So if we multiply by 1,000, then our decimal point gets moved 3 spots to the right. And it looks like this. 123.123, 123, etc. Minus our original fraction. Actually, let's write some more 123s for ease. You know, we can write as many as we want because it's infinite, so it'll always be accurate. So, let's see. 0.123, 123, 123, you know, so like something like that. So we subtract, and it's the same as before. We get a bunch of zeros, right? Boom, 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 and then 1, 2, 3. So we get 123. Okay, so we can rewrite what we just wrote, just like we did before. And again, we'll say that our fraction, our original fraction, this guy up here, times, what did we multiply it by again?
1,000.
1,000. Minus that original fraction equals what we got, 123. All right. So 1,000 F minus F is 123, 123. Let's simplify the left side here. 1,000 F minus F is what, Don?
999F.
That's right, 999 F equals 123. And now what do we do to simplify even more, Fiyera?
Divide by 999999999.
Divide by 999. And that's our answer. Okay. Now let's take a look at, can you see that? Yes, okay.
Yeah.
Let's take a look at what we see here. We see that, let me write it down here. Lost a 9 here. So 0.123 is the same as this.
1, 2, 3.
1, 2, 3, 1, 2, 3.
1, 2.
Is the same as this, and we had 0.333 ... is the same as 3 over 9. What are the similarities here, and what are the differences?
The decimal's the same number as, or the repeating number is the same number as the top number in the called what the thing called.
Yes, the numerator, good. So that's true.
Yeah.
You have a 3 here, a 3 here, a 1, 2, 3 here,
Then
and a
1,
1, 2,
2,
3
3,
here.
1,
Good.
2, 3 there. Yeah.
Uh-huh. What else?
That's all I got.
Okay. Do we notice anything else about the relationship between the original decimal and the 9 that we end up with in the denominator? You see anything?
3.
Mhm.
No.
No? Okay. So here's the interesting fact. So for this decimal, 0.333333, it's only one digit that's repeating, right? The 3.
Yeah.
The 3 is repeating. One digit here, one digit here.
Oh.
In this, 3 numbers are repeating. 1, 2, and 3. 3 digits here, 3 digits here. So now you know how to quickly convert any repeating decimal into a fraction, because it's just going to be whatever it is that's repeating over however many 9s that equal however many digits are repeating.
Oh, really?
Okay? Yep. So let's say
Crazy.
that we have 0.4567 repeating forever and ever. What would the fraction be?
4, 5, 6, 7 over 9999.
That's right.
9,999.
You got it. Does that make sense?
Yes.
That's crazy.
It is. Let's see. So let's do one more with these. Let's look at a number like 0.1666. So how is this one different?
1, 6, 6, because there's the 1 in the front.
That's right. We have a 1 here before we have our repeating digits, right?
Yeah.
Well, that's okay. We can still use our same method. So, since, let's see. Let's multiply by 10 this time. Because we have one repeating digit, right? That's 6. It's still repeating. Even though there's the 1 in front of it, the 6 is the one that's repeating. So, we multiply by 10. Oh, bless you.
Bless you.
Thank you. Sorry.
And we get 1.666 repeating, going on and on. And then we'll do the same thing. We subtract 1.666, our new number minus our old number. We get 1.5000, right? So we end up with 1.5. So again, let's rewrite our fraction into an algebra problem. 10 times our fraction, that's this, minus our fraction, that's this, is 1.5. 10f minus f, that's 9f, equals 1.5. We divide by both sides by 9, and now we get a fraction that looks like this. Now, what's the problem with this?
Hold on, I'm waiting for it to show up. That you have a decimal in the fraction.
That's right.
Yeah, that's messed up. You can't do that.
That's right, you can't do that. 1.5 is not an integer. To make a fraction, we have to have integers. So?
On 1.5.
So what do we do?
I have no freaking clue.
You have to multiply the 9 by 2, or its lowest common denominator, or whatever, I don't know. Multiply it by 2 so that 1.5 is no longer a decimal.
Fraction?
Okay, yeah, we could do that. So let's try and multiply it by 2. Multiply top and bottom by 2. Bottom we get 18. What would we get on the top?
3.
3. 3 over 18. We can reduce that.
Can we?
Yeah.
What? Divided by 3. 1 over
6.
1 over
6.
So this is that is 0.16666 is the same as 1/6.
Okay.
Okay.
The way that I have written down is we multiply by 10, but 3 is even better. So yeah, good.
Your big fat head's in the way a little bit.
Oh, me too.
I see it.
I said a little bit.
So I don't know. That's pretty interesting, right?
Yeah.
Yeah.
There's another way that you can do this. I found this formula on like a math forum.
Math forum.
Yeah. And what you can do is the
I
formula
love
is like
that
this.
Mickey goes on math forums.
What? What did you say about me?
I said I love that you go on math forums.
Sometimes, yeah.
That's me on HalloweenForum.com.
Yeah. So the thing
I don't
is,
think I go on forums.
x over 11 is the same as point B repeating. And the other companion to it is that B is 9x. So let's look at this one first. B equals 9x. Well, if we would take 9 times, give me a number.
2.
2.
7.
9 times 2. Okay, we can do both. 9 times 2 and 9 times 7. So 9 times 2 is 18. So B is 18. 9 times 7 is 20. No. 9 times 7 is 63. So B is 63. So on this side, we would have x, which is 2, over 11 equals 0.18 repeating. And if you put into your calculator 2 divided by 11, I guarantee you will get 0.18 repeating. Take a.
I'm going to fact check that.
What is it? 2
Wow.
divided by... Wow!
You did it!
Yeah. And if we did Dawn's, we would have 7 over 11 equals 0.663 repeating.
Yeah.
That's crazy.
Yeah. So I don't take credit for this. Some guy figured this out, but it's pretty cool.
Isn't
Yeah.
that true for most math stuff? Some guy just figured it out.
That is true. Yeah. Okay.
I love hearing those paper, whatever.
Paper crinkles.
Yeah.
Yeah, got my
The
notebook.
note.
Okay, so 9 shows up in repeating decimals.
First time chatter.
Hello.
Fascinating. Boy.
So 9 shows up in repeating decimals. So what else? What else can we talk about 9? What else is special about 9? Well, this is something that you might have learned in school. Let's look at the multiples of 9.
Is it the backwards forwards thing?
Yeah, it's partly that. So, it is the backwards forwards thing. Can you explain the backwards forwards thing, Dong?
When you multiply 9 by numbers 1 through 10, the 1 is 10 backwards, 2 is 8 backwards, 3 is 7 backwards.
Good.
4 is 6 backwards, right?
Yep, you're right. 4 is
Whatever.
7. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. And then 4 is 7, I think. So,
Wait, what's the backwards forward?
hold on, I'll show you.
Okay. 9 times 1 is 9, but then 9 times 10 is 90, which would be 09 backwards. And then 9 times 2 is 18, but 9 times 8 is 81, which is 18 backwards. And so on.
What?
Hold on, I'll show you. So we have 27. What's 9 times 4?
What? 36.
36. 9 times 5?
45.
45. 9 times 6.
54.
54. 9 times 7.
63.
63. 9 times 8.
72.
72. 9 times 9.
81.
81. 9 times 10.
90.
2 billion.
90. So we have 9, 0, 9, 9, 0. We have 1, 8, 8, 1.
Oh, I
2,
see, I
7,
see, I
7,
see, I
2.
see, I see, I see.
36, 63.
That's crazy. I never connected that.
45, 54.
That's like the one math thing I ever retained.
I'm always just like, it's whatever the number is times 10 minus the number.
That's
Just
right.
like,
Yeah,
that's how
that's
I
the
do
other
it.
trick.
Oh, I didn't know that one.
That's the other trick. Yeah. So if you did 9 times 3, well, 3 plus what is 10, right? 3 plus 7 is 10. And then this is the number before. 3 minus 1
I'm always
is
like,
2. So 2
3 times 10 is 30, and then that minus 3 is 27, and I'm just like, that's it.
Oh yeah, that's another good trick. Yeah.
I always have problems with my sevens.
Me too. I still can't do that.
I wish I had a trick for 7s. I don't.
Fuck 7.
7, 8, 9, you guys. 7's canceled anyway.
That's true. Okay, so if you look at these multiples, 9, 18, 27, 36, 45, let's look at these. Do we notice anything besides the backwards forwards thing? Do we notice anything like within these numbers?
It's going 9, 8, 7, 6, 5 on the left, or on the right. And
But
then
it's also
going
going
up
1,
on
2,
the...
3, 4,
Oh,
5.
that's crazy.
That's true.
What the
Yeah.
hell?
Yeah.
I never knew that.
Oh,
So yeah, that's pretty
That's-
weird, right? But that's not what I'm getting at. Well,
Oh.
let's just
what?
look at
That wasn't what you were talking about?
no.
That just blew my mind.
Let's look at just 18.
Okay.
Okay, so 1 and an 8.
That's right. 1 and an 8. What if we add
Wait,
those
wait,
together?
One,
wait, no,
I see.
God,
They
no.
add up to 9.
They add up to 9. What about 27? Does that work?
Oh,
Two-
no,
Yeah,
no,
plus
no.
seven.
crazy.
9.
It's 0 and 9? That works too.
Yep.
What the hell? 9's messed up.
Yep. It works for every multiple of 9.
Oh.
And if we take our backwards and forwards thing and we add those numbers together, so let's do 18 and 81 and 27 and 72.
Oh, God, what's gonna happen?
So let's add these. What do we get?
Freaking 99.
We get 99.
What
Just
the
like Toto said.
hell? What the hell? That can't be true.
So this
But it is.
this weird digital root thing is true for any multiple of 9 at all. And so I want you guys to give me to just type in a random number to your calculator. It doesn't matter how big it is. Multiply it by
Okay.
9 and then give me that number.
31. No, 311. 11.
You can just say the digits.
311. 112.
Like that?
Help me, God.
That's the load.
Yeah.
1, 2. Yeah.
Okay. So to take the digital root, do you guys know what the digital root is?
Freaking no.
Internet.
The digital root the digital root is when we add up all the numbers, all the digits in the number together. So we'll do 3 plus 1 plus 1 plus 1 plus 2.
Okay.
Okay?
What does that have to do with the internet?
Absolutely nothing. This predated the internet.
Your pluses kind of
What?
look bad.
They look bad. Yeah, I
Yeah.
was trying to write them fast. Sorry. Hold on, I'll make them better.
So
Thank
wait,
you.
the word digital meant something else before the internet?
Yeah, it means having to do with digits.
What the?
hell?
That's why it's like digital
What?
clock versus animal.
Oh,
Animal.
oh my god.
Digital versus
Animal clock.
analog.
It's because it shows the digits.
That's
Oh
right.
my god. Computers are made out of digits.
That's
I
right.
feel so freaking stupid.
I didn't know that.
Yep. Yes. So let's add all these together. What do we get?
Oh my god, I already can tell it's gonna be 9.
3, 4, 5, 6, 7, 9. I did it.
I'm sick. I'm sickened.
So all of these, if we add them up together, it comes out to 9, which is true of any multiple of 9. Let's try it again.
No. I have one.
Okay.
174, 105.
105.
That's not going to equal 9.
Okay. 1 plus 7 plus 4 plus 1 plus 0 plus 5. Okay. So let's add them.
Ugh.
Okay, 1 plus 7 plus
It's
4
18, right?
plus 1 plus 0 plus 5.
It is 18, so it's a
18.
multiple of 9.
Uh-huh. Okay, so let's add 18 up. 1 plus 8.
Oh my god.
Oh, shut up.
God damn.
Shut the hell up.
So,
Shut your
I
mouth.
forgot to mention that the digital root needs to be 1 digit. So if you get a 2-digit number or anything bigger
Shut
than that,
your mouth. Shut your
I'll
mouth.
do that.
Shut up.
Can we do a really big one?
Yeah.
I'm like one of a child. Okay, ready?
Yep.
2, 1, 1, 9, 2, 1, 1, 0, 1, 0.
Okay. So let's see. So we have 2 and 2. This is 4. 2 and 2. This is
It's
4.
gonna be 18 again.
8 plus
Oh,
1,
really?
that's 9. 9 and 9, 18.
Damn.
Oh, goddamn.
And then 1 plus 8 is 9. Digital root is 9.
Okay. Okay, hold on. Hold on. Hold on. I'm gonna get
Hold
you.
on, we have to get a bigger number.
Hold on. Okay, I have one.
Okay.
4, 9, 9, 0, 1, 0, 6, 7.
Okay.
Okay,
99
now
is
everybody
18.
Everybody get their credit card out and multiply the number by 9 and tell us what it
And type it in chat.
Yeah.
And then the number on the
we can
back,
do,
multiply that by 9. And type it in chat. And then just give us the date so we know.
Right. It'll help.
Done.
36. Oh. Is
Anybody
your
else get
social
any
okay?
multiples of
Yeah,
9? they
give
wanna
us
try?
give us your social times 9.
Okay.
And type that into chat. Social security number. SSN for short.
Your, and then if you do that, definitely do like your address numbers
Mm-hmm.
and your phone number. 999 999.
Okay, is that your multiple of 9 that you want?
Yeah,
Okay. 999.
that's what Veronica wants.
99999.
Oh no, I guess that's Veronica's social security number.
She was the first
Times
person
9.
ever.
That's crazy. I will steal your identity. Don't mess with me.
Damn. What's 7 plus 7? 14, is that right?
Yeah.
What if you
Wait, I think I did it
multiply-
wrong.
Yeah. multiply your mother's maiden name by 9, and then also multiply like the first street you lived on, and your first car, your first pet. Multiply all those by 9, and your PIN number too. 54 plus 18.
It's 72. 72.
72. It's 7 plus 2 is 9. I just don't believe this. You know what I would say? 9.
9.
That was a little German joke for all of you.
I liked it. I liked the German joke. Well, that's crazy, right?
Yeah, it is.
Let's get into
Don't
more
tell me
crazy shit.
Or, oh my god.
What were you gonna say?
Nothing. What the frick's gonna happen next?
So another interesting thing about 9 and the digital root is that it also affects non-multiples of 9. So we learn something if we find the digital root of other numbers. Okay, so let's take a number. Woo!
Woo!
Any number. Give me a number.
7.
7. Okay, let's 7 is fine. What's the
no,
digital
what do you
root of
want?
7?
Do you want a better one?
I'll
We can
give
do
you a
7.
better one. 7, 2, 8, 9, 7, 3, 4, 1.
Okay.
There you go.
Okay. Let's take the digital root of this guy.
Okay.
Oh, I shouldn't have had so many high numbers. Should have just said 1, 1, 1, 1, 1, 1, 1.
7.
Anna Maria Inc. is here.
Anna Maria Inc. You're not a vampire. Why are you talking like that? What are you gonna do next? Say good evening?
Good evening.
Oh my god. I like that we're just making... I'm not adding these up. I'm just watching
Me
you.
neither. Me too.
You guys are the students. You need to add this up.
No. I'm taking notes.
It looks like you're doing it.
You're the teacher writing on the whiteboard, and I'm sitting back here taking notes.
I literally. What? Go ahead.
I think I lost my place though.
I think you did it, didn't you?
7 and 2 is 9. And 9 is 17.
7 plus
5.
2
7
plus 8
2
plus
8
9
plus 9
plus
plus
7
7 plus 3
plus 3.
plus 4 plus 1 is 41.
Okay.
Yes.
Digital root is 5.
5.
5, not 9. Gotcha.
Well, we're not done yet.
Why not?
Okay. So, our digital root is 5. Well, this will tell us something about this number. So keep the digital root in mind. Now let's divide this original number by 9. 7,
The original
7,
number?
2, 8, 9, 7, 3,
7,
4, 1.
2, 8, 9, 7, 3, 4, 1. Okay. It's kind of a mess.
Okay, now I want to do this traditional long division style.
What? No!
Because what we want is a remainder. We don't want like a decimal. So how many times?
Well, I can tell you
Mm-hmm.
from your teachings what it is
Yeah.
with the fraction.
Okay.
So the fraction that we're gonna have left over is 5 over 9.
Okay, good. 5 over 9. So, do you remember what the quotient
the last one was 5. Yeah, it's 8,099,704.
Remainder 5. 5 over 9, right?
And then 5 over 9.
Okay. So, what do we notice?
Which I hate that. So there's always the original digital whatever, and over 9.
Yeah, so the remainder, whenever we divide this number by 9, is going to be the digital root of the number. Let's try it again.
No.
All right, Dawn, give me a number.
756.
Okay.
Is that okay?
That is good. That's a good number. Let's find the digital root.
Okay.
That number wasn't good? Okay.
I
11
said I
plus
could do it.
18.
18.
18.
Aha! Now the digital root is 9 then. So we know that this number is a multiple of 9. So if we divide it by 9, we'll get a whole number. So go ahead and try that.
What?
Divide 756 by 9. 5 by 9. 84.
84. So it is a multiple of 9. Okay. Let's try...
Oh, sorry.
No, it's fine.
Nice going. So it wasn't a good number.
So let's try a 1 off. Let's try 757.
Fine.
Let's see what we find out. What's the digital root of this?
19.
19. 1 plus 9.
19.
10.
And what's that? Would it just be 10? 1.
Yep. Digital root is 1. Okay. Now let's divide it. And we know... Sorry, by 9. And we know that it goes into it 18 times, right? 18 times 9, 756.
And then it would be
Correct.
1 over 9 left.
That's right. Remainder 1.
I hate that.
But do we notice something about when we go from a multiple of 9 to a non-multiple of 9 that is directly adjacent? So when we start with our multiple of 9, 756, which is 9 times 18, 757 is 9 times 18 plus 1. Right? Which is why we know it has a remainder 1. That's what a remainder is, right? It's however many times the number goes into the other number plus however many extra, right? So that's why it works. That's why the digital root thing works. Because if we're dividing it, then we're saying to ourselves exactly that. How many times does it go in with that many extra? And the reason why the fact that it's 9 and this works with digital roots of numbers is the fact that we have a base 10 system. So 9 is the penultimate number. So it's everything is resting on 9. If we had like a base 6 system, then everything would be resting on 5, and we would be having a math chat about 5 right now. But we don't.
In another universe.
Why 10?
Why base 10?
Yeah.
A lot of different theories on that. I think that the best one is probably that we have 10 fingers and 10 toes, and so we count on our fingers, and that's how we made our number system.
Maybe you do, freak.
But I mean, there have been different number systems throughout the world. I would love to do a math chat about the base 12 number system that is pretty popular.
Where do they do that?
I don't know that they do it like in any particular culture now, but it's like a theoretical thing that mathematicians are like, wouldn't it actually make more sense if we use base 12? And so they explore that. And
What did the Egyptians use?
I don't know.
Is there math people? But you gotta learn that.
Yeah, I'd
Look
like
it
to
up.
know.
You could have King Tut on the stream.
Could, yes.
You have that recording of his voice that they made where it's like, ah!
What are you talking about?
You know what I'm talking about.
No, I don't.
They recreated his vocal cords in like I don't know, blender or something. I don't know.
In
Some
a
sort of
blender?
digital in some sort of digital program,
Oh, okay.
and they ran it to see what he would sound like, and the sound that it made was just ah. I'll send you a link. It's very funny.
That's really good. I know
I
that.
just looked it up, and Egyptian is base 10.
Okay. I
The
know
number-
See,
that
that's why they're smart.
King Tut was born in Arizona. That's the main thing I know about King Tut.
Yeah, then he moved to Babylonia.
Yes.
The numbers 1, 10, 100, 1,000, 10,000, and 100,000 each had their own hieroglyphs.
Aha. Can you look at base 12 and see if they use it anywhere right now?
Base 12. Duodecimal.
What? This says the Egyptians used base 12, but Wikipedia just said it uses 10. What is the truth?
Well, they might have used both.
Babylonians
that-
used base 60,
Yes.
and the Mayans used base 20.
I didn't know that one.
It says that it Germanic languages
Mm-hmm.
and also languages in the Nigerian Middle Belt used it,
Mm-hmm.
and Old Norse maybe,
Mm-hmm.
and units of time are surprisingly
Base
duodecimal.
12.
Yes, they are, yeah. Which is confusing.
So
Yeah.
Although I don't know if I can support a switch to a decimal clock, because that would just mess up everything.
it would. Okay, that's interesting.
They should change it so that there's 100 minutes in an hour.
Yeah,
No,
that would
I
be a
don't like
decimal
that.
clock.
I don't like that though.
And then there would be
It's
10
too
hours in a
many.
day or something like that.
That's too many.
Mm-hmm.
Think about how much more you could get done.
It would be the same amount of time.
But then they keep
Yeah,
you
time would not change.
they'd keep
just
you
the
at
numbers.
work longer.
That's true. They could keep you at work longer.
This is directly related to the video that Veronica sent me the other day, where it was like different languages and how they talk about time and how that affects their perception of time, and it's super cool.
Wow.
By Native Lang on YouTube.
Wow.
Alright, so just to recap, so the digital root of 10 is 1, and it's 1 more than 9. And digital root of 11 is 2, and it's 2 more than 9, and so on. So the rule, what's the rule, guys?
It's something that a rule is something that sets things in place and that people usually have to follow. That's what a rule is.
Okay, what's the rule that, involving digital roots and when you divide it by 9? What's the rule?
9.
It's whatever the original thing digital root is over 9.
Yeah, so the 9 will go into the number however many times, plus the extra will always be our digital root. All right.
Okie dokie.
All right, so let's go back to our trick. Do you guys remember your numbers?
Oh,
Shit. Yes, hold on. I got it.
Hold on 1 second.
All right, Dom,
Yes.
give me your number. Give me your original number, then just walk me through what you did.
Okay. I did My original number was 4,123.
Okay.
Then I subtracted that by 2,341,
And what'd you
which
get?
gave me 1,782.
And we know that that's a multiple of 9.
Correct.
But why do we know that it's a multiple of 9?
I don't freaking know.
Well, it has to do with the digital root. So let's take the digital root of our original one. 4 plus 1 plus 2 plus 3. What would that be?
10.
10? Yeah, 10. Okay. 10, so it would be 1,
Wait.
right?
What it? 8? Yeah, 10.
Yeah, 2,
What?
3, 5, 4, 1, 5, 5, 5, 10. So
Yeah.
our digital root is 1. So we know
Okay.
that the digital root of this guy, since it's just all the same numbers, it has to have the same digital root, right?
I think so.
Thanks to the commutative property of addition, right? It doesn't matter what
Yeah.
order you add things in, as long as they are the same, it will be the same sum. So we know that the digital root of this guy is 1 and the digital root of this guy is 1. So we know when we subtract them, the digital root of the remaining number will be 0. Aha! But, just like we said, we live in a base 10 system, right?
Yeah.
So a digital root of 0 is actually exactly the same as a digital root of 9. And if a number has a digital root of 9, we know that it's, remember? This was the first thing we did.
Digital root of 9?
If it has a digital root of 9, then what do we know about the number?
It's a multiple of 9?
It's a multiple of 9, exactly. So that's how I knew for sure that no matter what your difference was, it was going to be a multiple of 9, because I knew it would have a digital root 0, which is the same as having a digital root 9. Let's do fees now.
Okay. Mine is very long.
Okay.
7, 8, 2, 0, 1, 5, 4.
Okay. And what was your second number?
5, 0, 2, 7, 4, 8, 1.
Okay. So digital root of our first guy here.
Oh boy.
So we have 10, 10, 27. So 9, actually.
Huh?
Right? 1 and 4 is 5, 5 is 10. 10, so yeah. So this one has to be 27, which is 9. And 9 minus 9 is 0. So what was your
How
new
did I
number?
accidentally pick one? Oh my god. So what was what?
What
What are
was
you
your
asking?
remaining number?
2, 7, 9, 2, 6, 7, 3.
Okay. So we know that this is a multiple of 9 because the digital root is 0.
Wow.
How did I accidentally pick something that was a multiple of 9?
Yeah. So the good thing is that it works even on multiples of 9, so we are all good. All right, so now I want you guys to secretly, this is our last thing, I want you guys to secretly circle or just think of one of the digits from your difference. So from so Fee, you will do this second number here.
I did it.
Dawn, you will do this
Oh, from
number.
the second number?
Yeah.
Not the third?
The third, yes.
The third.
Yes.
Okay.
The answer.
The difference, yes.
Yeah. Okay, I got it.
All
Me
right.
too.
Oh man. Actually, this doesn't work because I know your numbers now. So you have to do it again. Sorry.
I have to make new thing?
Yeah, do the same thing you did before. Take a number,
What did we
scramble
do
the digits,
before?
and then subtract.
Scramble and then subtract. Okay.
Original number. New scrambled. Difference.
Okay.
Okay, I have it.
I don't. Hold on. Okay.
Okay, so you guys got both of your differences?
Yes.
Okay. So do what I said, circle or think of a oh, bless you.
Jeebs.
Sorry.
Bless ya.
A particular digit.
I did.
Okay.
Okay. All right. Now, Dawn, I want you to read me your remaining digits, not the secret digit, but the remaining digits in any order you want.
Okay.
Well, you're just okay.
19091.
19091.
I know how you're gonna do this.
I don't. I have no
digit is
idea what's going on.
I think your digit is 7.
Yeah.
Okay.
What?
It's because it just adds up to 9.
What? Oh.
So I added up all your numbers and I got 20. And I knew if I added 7, I would get to a multiple of 9, 27. Let me do yours, Fiyera, and then we can go.
That scared me.
331.
Wait, can I guess it?
Yeah, go ahead.
Yeah,
Okay.
mine's pretty
3,
easy.
3. Whoops. 3, 3, 1. Okay. 2.
Yep, you got it.
Very nice. Because we got 7. If we added 2, we got to a multiple of 9. 9. All right.
Yeah.
Good job, you guys.
Holy smokes, that was freaking crazy.
That was. I was not expecting it to be that crazy.
Yeah. 9 is my favorite number, and now you know why.
5 is my favorite number.
5 is a good number.
What's your favorite number, Dawn?
I'm not gonna say it because it's in a lot of my passwords.
Okay. I guess that's fair.
And here's a hint.
It's 8.
This is the next math chat.
Oh. Okay,
Oh,
you
it's
drew
the
a circle and then a long circle, and I was like, uh-oh. Flower.
Fibonacci.
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 Golden ratio, 5.
Snail. Excuse
Bless
me.
you.
Okay. Thank you so much for coming, you guys. I hope that you learned a lot about 9.
I actually did.
I did too.
Yay.
Thank you, teacher.
Thank you. Thank you, Mr. Sparkle.
Thank you, Mr. Sparkle.
You're welcome. Okay, guys.
Wait,
What?
who was your favorite student?
Benny.
Oh!
What the hell? Benny wasn't even. Benny was just doing this virtually.
I'm just kidding. All of my students are my favorite. You guys all did so well.
Yeah, sure. That's what they all say.
Okay, folks. Sparkle and shine. Thank you so much for coming. Join the 3 of us, actually, tomorrow for some Toontown rewritten.
Yes,
Rewritten.
have not determined the time yet.
Have
But
not
will.
determined the time, but we will be doing it, and it'll be a lot of fun.
The rest is still unwritten. You know that song?
Yeah, I do.
Yeah.
I like that song.
She wrote that for
She-
Toontown.
She
Yes, she
says some
did.
numbers in that song.
What? She says numbers in that song?
Yeah, doesn't she?
I don't think
No.
she does.
No, I don't think she does.
Okay.
Are you thinking of her other song where she says chord names?
I don't think so.
D, E, F, and it's actually D flat.
No. It's fine.
Okay.
I don't think she says number. She said
She does not.
standing at the window.
Open up the door, window.
At the sound of the wind, where you're gonna find nature is happening. So in the shoes, feel the rain on your skin. No one else can do it for you. Only you can have it. And the best, no one else can think of it. I hope everyone enjoyed.
Do you think we'll get DSTA strikes for that?
Yeah, it sounds exactly
Yeah,
like
we
the
were just
original.
so good. I hope everyone liked my high note. Well, Mickey was going.
Aye.
Okay. Bye-bye. Sparkle and shine. Gule
Bye-bye.
gule.
Bye-bye. Gule, gule.